All right, welcome back. Hononegah Honors, Algebra 2. 9-3 AC, again, alternate current 2. We're now going to start solving equations using the knowledge that we just learned in the last section. So again, if you were going to solve this question, and this was one that you probably could use a calculator on, and you would at least get one answer. But if I had the sine of x equals a half, I would take the inverse sine of both sides. So x would equal inverse sine of a half. Well, this is exactly what we just did in 9-3 AC is we drew opposite and hypotenuse. Okay, so the opposite side is 1, the hypotenuse is 2, found the missing side, found the reference angle, so this is a 30-degree reference angle. And because our restraints are from 0 to 2 pi, we're going to get two answers here. We're talking about pi over 6. Every 30 degree is a sixth. And then we're talking about 5 pi over 6 in the second quadrant there. Your calculator, if you did this, your calculator only gives you one answer. So your calculator, if you typed in inverse sine of a half, would say 30, which is pi over 6. The trouble is it's not going to give you the other one, which is 5 pi over 6. So solving an equation, first I have to get the trig function by itself, take the inverse cosine of both sides, and so the actual question that I'm asking you is, what angle measures have square root of 3 over 2 as a ratio? Drawing positive, so adjacent over hypotenuse, and the other one in which it's adjacent over hypotenuse would be in the fourth quadrant. Find the missing side. So the missing side is 1. That is a 30-degree reference angle. So again, two answers here for 30 would be pi over 6. We just did that in the last one. But then this one going all the way around the circle would be 11 pi over 6. Again, every sixth is a 30-degree reference angle. So in order to go all the way around the triangle, then I am 30 degrees short of 2 pi. So that's one way of looking at it, is how far around the circle do you need to go in every sixth. So some of you probably need a little bit more explanation on that, and please make sure you're reaching out to Ms. Kinsel and myself. Solve for the trig function. So I'm going to subtract 1 and divide by the square root of 2. And then I'm going to take the inverse sine. So the actual question that I'm asking here is, what is the inverse sine of -1 over the square root of 2? So I want the opposite side to be -1, the hypotenuse to be 2. So the opposite side to be -1, and the hypotenuse to be 2. Find the missing side. So you're talking about 1 square root of 2, which is a 45-degree reference angle. So going around here, every fourth, okay, so going around that would be 5 pi over 4 in the third quadrant and 7 pi over 4 in the fourth quadrant. Solve for your trig function and then take the inverse of both sides. So the actual question that I'm asking is, what is the arctan or inverse tan of the square root of 3? Drawing a positive, opposite over adjacent. So again, if it's a positive, you can have a negative, and it would still be positive. Find the missing side, so we're talking about 2. This is a 60-degree reference angle. 60 degrees is every third, so pi over 3 in the first quadrant, and then 4 pi over 3 in the third quadrant. Now this goes above and beyond, okay? They want to get all the trig functions on the same side, so I'm going to add sine of x to both sides, which gets me 2 sine of x. Then I'm going to solve this for sine of x, so I'm going to subtract the square root of 2 and then divide by 2. Unrationalizing this would be the same as -1 over the square root of 2. So I need the opposite side to be -1 and the hypotenuse to be the square root of 2. So that is located in the first And that is located, sorry, in the third and fourth quadrants. The missing side reference angle would be 45 degrees. And so now I need the answer in radians. Third quadrant, this would be 5 or 1 and 1/4 pi. It would be 5/4 pi. And then going all the way around, this would be 7/4 pi. Getting the tangents on the same side, I'm going to add 2 tangent to both sides, which gives me 3 tangent. I then am going to solve this, so I'm going to add 3 and divide by 3. I'm going to get tangent of x equals -1. And then I want the inverse tangent of 1. That is located in the first quadrant, opposite and adjacent being 1. It's also located in the fourth quadrant because a negative and a negative. So we got a 45-degree reference angle, and now I want the answer in radians. Every fourth, so pi over 4 would be in the first quadrant, and going around then 5 pi over 4 would be in the third quadrant. So I feel like I need at this time maybe to talk about this, and I realize that some of you are going to struggle on this, but I'm going to go off topic here just a little bit. Let's scroll down here. I think some of you need to understand 30, 60, and 45 in radians. So if I have a 45 going around, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If I have a 30 going around, so it's a 30-degree reference angle, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 going around. And if I have a 60-degree reference angle, in the first quadrant's pi over 3, second quadrant's 2 pi over 3, third quadrant is 4 pi over 3, and then 5 pi over 3. The other ones are all quadrantal. For instance, if I did 3/3 pi, that's just pi and it's on the axis. If I did 2 pi or 6/3 pi, that's on the angle. So again, these are the angles for 45, this is the angles for 30, and this is the angles for 60. And I probably should have done that a long time ago. So again, that might be something that I add as a little bit of a video, but this is something, a little alternate content here, understanding where each of the angle measures are located. Solve. All right, sine squared x equals 1/4. Take the square root of both sides. So sine of x equals positive and negative 1/2. And so I'm going to do arc sine of both. So I need the inverse sine of 1/2, and I need the inverse sine of -1/2. So instead of just getting 2 answers, I'm actually going to get 4 answers. All right, so I'm going to draw 2 pictures here. Probably make more sense. So I need an opposite and a hypotenuse. That's +1 and 2. Find the missing side. And the ratio, this would be a 30. From what we just talked about before, that makes a pi over 6 and a 5 pi over 6. So there's the 2 answers for +1/2. Now, -1/2. So the opposite side is -1 and the hypotenuse is 2. Find the missing side if you want to. This is a 30-degree reference angle again. And so now in the third quadrant, we're talking about 7 pi over 6, because every 6th is a 30-degree angle, and 11 pi over 6, because every 6th is a 30-degree angle. So instead, because this is plus or minus, instead of getting 2 answers, I'm actually going to get 4 answers, 2 for the positive and 2 for the negative. Same thing for cosine. So I got cosine squared x equals +1/2. Square root of both sides. So cosine of x equals plus and minus 1 over the square root of 2. Just leave it that way. Inverse cosine. So now the 2 answers I want the inverse cosine of positive. Then I also want the inverse cosine of negative. So again, instead of getting 2 answers, I'm actually going to get 4. I usually try to draw this as 2 separate pictures. So positive adjacent to hypotenuse. The missing side would be 1, which makes a 45-degree reference angle. So the first quadrant is pi over 4, and the fourth quadrant is 7 pi over 4. Now for the negative, I want adjacent to be negative and hypotenuse to be the positive square root of 2. 45-degree reference angle. So now in the second quadrant, that is 3 pi over 4. And in the third quadrant is 5 pi over 4. So again, 4 answers here. Homework assignment, again, this is not necessarily something new, but it's just done in a different way. So instead of doing just telling you, finding the arc sine of something or finding the arc cosine or inverse cosine of something, now I'm going to solve an equation and use inverse cosine. If you have any questions, make sure you're talking to myself and Ms. Kensel. If there's anything that I can do for you, we will help in any way we can. We understand that this material can be challenging. Good luck. Be safe.